Today we will solve very interesting problem. There is a triangle ABC area we need to find out. There is an interior point P. There is a line drawn from all the vertices passing through the point P and which is touching to the opposite side at the point FDE. So that it formed the many triangles here. There are the given few triangle areas already given here. We need to find the total triangle area that we can achieve by just finding the triangle APB area is X and the triangle EBP area Y. If you find these two, then you can just sum up all the areas, we will get the triangle ABC area. So we need to find the triangle ABC area. For that we need to find the X and Y values here, right? So this problem can be solved with just triangle area principle, that is half into base into height. I made a couple of shots to understand better way to this formula. Please go through it. Let me take AF line. Okay. So in the AF line, what are the line segments we have? AP is the one line segment and PF is the another line segment. So let's see, by having these two line segment, what are the areas triangles are forming having the common vertices, opposite vertices. For example, if you take triangle APB, so we have this base AP here and the opposite vertices is, what is the opposite vertices is B is the opposite vertices. So in that line, in that same line, if you take another triangle PBF, so it has the line PF here, so PF is the line. So these two lines is the parallel or inline, like coincident lines, right? But different length of the base. AB is the one length and PF is the other length. But opposite vertices to this triangle is PBF triangle is same B, right? So if we draw a line from the point B to this line, okay, let me draw. Okay. So where it will come? It will come somewhere here, right? Somewhere it will come here, right? So let's think that this is a perpendicular line, okay? So if we draw a line, so both triangles having the same height. That's where we are using these two triangles. Why cannot use the other triangles? You can ask me the question. That's why I am explaining. So in these two triangles ratio, if we take it, the height will be get cancelled and the off into base, right? Off will be get cancelled, so that we will get the ratio of the AP by PF, right? Similarly, the right side, what are the triangles containing the same base here? If you take the APC is the one triangle and another triangle is PFC. If you take it, it has the same opposite vertices at the same line, so that height is get cancelled, right? So now what I am trying to do, right? Let me write the area of ABP, okay? ABP, okay? Upon area of PBF. So these two triangles common B point is the opposite vertices, right? So triangle area is off into base into height, right? So these two triangles having the same height and off anyhow it's a constant. So that it just became like base ratios. That is, for the first triangle the base is AP and the second triangle the base is PF, right? What is the area of the ABP here? ABP area here, 84 plus Y, right? So it is just 84 plus Y upon, and here PBF here is 40, right? Equal to AP by PF. Now, similarly, we do the right side. Just the same AF line. Using the AF line, we will find the right side triangles having the opposite vertices C here. Okay. Let's fix this C here. So, first triangle, area of APC upon area of PCF. So, here I am using this base. AP is the first base, second base is the PF. The opposite vertices C here. See, if you draw perpendicular line here, that is getting cancelled. So, it is just like now base ratios. That is AP by PF. So, what is the area of the APC here? It is x plus 35, right? X plus 35, 1, it is 30, right? Okay. Equal to AP by PF. If you see the right side one from these two equations, it's the same. We will equal now the left side terms here. That is 84 plus y by 40 must be equal to x plus 35 by 30. Let's take this the equation number 1. So earlier we have used the line AF, right? Now similarly now we will use the line BD line. Let's take the BD line. Okay. So I'll show you the simple way to write directly. Okay, here. So BD line, what are the ratios we are trying to interested here? So BP by PD, right? BP by PD. Okay. So these are the ratios. So directly you can write this step. Let's see here. For example, I'll write here area of this one. We are taking common line, right? So the above triangles and below triangles, let's see which is having the same corner. Okay. So if you take this triangle here, first you will take this triangle here. Okay. And another triangle is this triangle. Clear? So the same opposite vertices, both lines are the parallel, right? So area of ABP by area of APD. So this ratio. Similarly, if you write down below area of BPC upon area of PDC. So for these two triangles, the opposite vertices is same, like C. And these two lines are in line. Okay, if you draw perpendicular line, the height is get cancelled. It is just the base ratios. What is the base ratios? Here BP by PD, right? So similarly, the top side also, if you are checking right, this is just coming like BP by PD here. Okay. Now for this line BD line, the above we have divided the two triangles and below we have divided the two triangles, so that we have the same ratio of the BP by PD here. So that we will equal into the left side terms. So the first side terms, if I write it here, what is the area of the ABP here? ABP here, 84 plus y, right? APD is the x, right? Okay, is equal to BPC. BPC is the 40 plus 30 is the 70s area. 40 plus 30 upon PDC is 35. 84 plus y by x equal to 70. 70 by 35 is 2, right? So let's take this the equation number 2. So from the first equation, if you simplify it, here the 0 zeros get cancelled. Here from here 84 plus y can be written like 2x, right? So 84 plus y I am just writing here 2x, okay, by 4 equal to, this will become like x plus 35 by 3, right? If you cross multiply it, we multiply it, it become like 6x equal to 4x plus 140. So it become like 2x. So 4x, if we bring this side, 6x minus 4x is 2x equal to 140. So x is equal to 140 by 2, that equal to 70. Right? So now we have the x here. We can find the y by substituting any of the equation here. For example, I will substitute in this equation here, this one. So it becomes like 84 plus y equal to 2x, right? So 2 into 70. So y equal to 140 minus 84. So 140 minus 84 is, so it becomes like 56. So finally we found the x value as 70 and y as 56. Okay. So now how do you find the total area? We need to add all the numbers, right? So that is area of the triangle ABC. So that equal to, we need to add up all the areas. That is 84 plus 40 plus 30 plus 35 plus x and y, right? What is the x? 70 is the x and y is the 56. 315. So the answer is 315 for this problem. I think that's all for now. I think if you are not understanding anything in this, please write in comment section, okay? I will try to explain, or I will take any short video to understand better. Thank you for watching.